Hi lads, in this video I'm going to go through how to 2014 section C2 higher level question. It tells us the graphic on the right shows the clubhouse of the Dubai Creek Golf and Yacht Club. The design of the building was inspired by the sails of a ship. The projections of part of the structure are shown in figure C2 below. An isometric view is also given. The curved surface is produced by translating the generating parabola ABC in a vertical position along the parabola EBD. The generating parabola ABC is represented by a dotted line in the outline end view. B is the vertex of both the parabola ABC and the parabola EBD as shown. Part A, draw the given elevation of the structure. Part B, draw the end view of the generating parabola ABC. Part C, project the plan of the structure. And Part D, determine the true shape of surface AEC. So to start this question, I'm going to draw out my elevation and my end view. So with the parabola given, I'm told to the scale of 1s to 100, so I need to divide out all my measurements there. So for example, the first one there is telling me that the height of the parabola is 7.5 meters, so 7,500 millimeters, divided by 100. And that gives me a total height of 75. So I'll just take a line across there for the top of my view, and I'm going to measure down 75 and take that line across as well. So for the widths, I'm told for the distance between E to B is going to be 6 meters. So that's going to give me 60 mil. So I'm going to start that roughly about here. So I'm going to cross 60 mil for that. And then I'm going to go across 150 after calculating 15 meters. And they're going to give me my widths. Just put a space in between my elevation and end view, and I'm told the width is 12 meters, which is going to be a total of 120. So 60 is going to be the middle point. So to draw the actual parabola, I need to use the rectangle method. So for the rectangle method, you take a random line out any side. And what I'm going to do is divide it into 4 equal parts to get my points. So 1, 2, 3, 4, and then connect them side there, and then use sliding set squares for the rest of it. And all these points are going to connect to the top. Label this A, B and C, and what I can do is I can take these points across here and just dot them across the other side, saving me dividing this side up as well. I can now connect these points to the top as well. So after dividing the sides into 4 equal parts, I now divide half the base into 4 equal parts as well. So let's take my line out here. Same idea again. Divide into 4 equal parts. I'm making sure this time to connect to the center point there. and not divide the whole base into 4 equal parts. What I can then do is I can take them points up to meet the lines across. So 1 point there, 1 point there, and 1 point there. Now give me 1/2 of my parabolic curve. I know what to do simply is, instead of dividing the other side up, I can take these points across to meet it. So it gives me a point there, there, and there. And now I can draw in my parabolic curve from my end view. For the elevation, it's the exact same thing again. This time we're told that we have a curve running all the way across, starting from here, eventually reach this top point, the vertex here, and continues on and stops at this edge here. So we do the same idea again. We'll divide our sides into a number of equal parts. Because of the actual width of the base, I'm going to divide that into, you see in the question, it tells us here, we're to divide it into 1, 2, 3, 4, 5 equal parts, because we're actually going to use these lines here to determine the widths. So we divide into 5. So we're actually told it's 150, so divide into 5, we can just go 30mm gaps in between. And they're going to be all of our heights going up. And then all we do is divide our actual height here into 5 equal parts. So I'll do is just take a line out here once again at a random angle, set my compass, and take 5 equal distances once again. And we then use sliding set squares to take our points up. So we now have all of our heights there, and now what I can do is connect them to our vertex at the top here as well. And we have a series of points located all the way along there as well. And the last thing we need to do is draw a curve on this half, and then we can plot our points across for the opposite side then as well. So there's one side of our curve, and what we can do is we can just take our points across here, and step our distances across. And you can see just by using 2 points there I've enough to actually take me around. And then out to know where the curve is actually going to stop. So now I can draw in my curve in nice and neatly heavy there. And then just label our points. So I have ABC in my end view. I have point D here. AC are my center points here and here. B is my point on the top. And then E is my point that extends out and hits the surface at that point there where the curve actually eventually hits out. And then I can connect CA to E there, and then just draw in heavy my baseline there. So that's all I'm able to do now from actual elevation end view. That's actually completed. So the next part is actually drawing in the plan. To draw in the plan, I'm going to take all of my points down for what I have so far. So I can take down E there, A, B and C, and D comes down there as well. And then using my 45-degree set square, I can take points A, B and C all down at 45 degrees. And take them across to where they end up going. So A, follow A down across, gives you point A here. C, take it down across, gives you this point here. B, taken down across, is here. And then D is going to be here, and E is going to be sticking out on this side here. So what I need to do now is actually draw my curved surface that's going to appear all the way along between A, D and C. So in the question, if we go back to it, just get it up here on the iPad again, it tells us here that the curved surface, so this sentence here, is produced by translating the generating parabola ABC in a vertical position along the parabola EBD. So what's happening is basically the parabola ABC is a certain size. This is the size the parabola is here. But as it's going back, that parabola is getting smaller and smaller and smaller until it eventually becomes a point. And the way it's getting smaller and smaller and smaller is being determined by this parabolic curve EBD. So that's the height of the parabola. Each of these cuts here are a new height in the actual parabola. So the parabola's true height up to here was the height from AC to B, and that's given here as our true shape there. So what we need to do is find out the widths of that parabola, so we can plot the widths along here to produce the curve from taking the height of what the new parabola is going to be as it gets smaller and smaller. So to show that, I'm going to use colours, as this can become quite messy when you're actually solving it. So with the first one, I'm going to take this point here. So one of our widths we were given. So we had to divide this into 5 equal parts, basically using 30 mils all the way to get 150. That pink distance there, if I take that on my compass, so the height from there to there, I mark it from the top of this one, I'm going to get a width. So I just show that in pink there again. Them two distances are the exact same taken from the vertex of the parabola. I'm going to get two widths from that then as a result. And they're both the exact same. These two widths here. The distance from here to here is the same as here to here. I'm going to then use those widths then as my new width as the parabola gets smaller and smaller and smaller going down. Obviously if it gets smaller in height, it's going to get narrow in width, which is going to give us this curve here. So I take that width down there, take it at 45 degrees, and take it back, and it'll hit our pink line there. And what I can do is I can extend that out, and just take that distance of my compass and just swing it around this side here, and that'll give me my width for the lower half. I then repeat the process again. I'll choose a different colour this time. This time I'm now going to take this height for my parabola. So I'm going to use that height and figure out, based on this parabola here, if I take that height instead, what would be my new width. So I stretch that down to there, and I'll put the orange in just beside it. So you can see my orange width there, or sorry, my orange height. I can take that across. So it's going to give me these two widths here. They're both the exact same. And I can take that there. Instead of taking it down and around, another way I could do it is just take that line down and just mark it each side. So there and there. And I repeat the process for these two here as well. I'm going to take my heights, mark them from the top, take my widths, and mark them each side once again. And then finally my last one, let's take these lines down here, take my height here, mark it from the top, and now take this width. And I apply it to here and here. And that's now giving me a series of points that I can now draw my curve along. Now if you wanted to, you can see there's a bit of a gap in between. You could just add a few more points along the way if you want to take another one there. Something wrong with actually doing that, but the main one is just you use the points you're actually given. So there's nothing wrong with in the exam actually taking one more and saying that to make sure your curve is perfect and you're happy enough with it. You can take another set there, take your height, mark it down, and once again take your width and just mark it there and there. and just gives you another 2 points to actually have, but the main ones you are to use are the ones given to you, and then you can use any additional ones you want after that. So after that then, all you have to do is actually draw in your freehand curve as best you can using the points given, and the same on the opposite side. And that'll give you your curve in your plan. And I'll just go over it heavy. And for the curve on the right hand side, or sorry, the left hand side, lads, we just repeat the process and we can just take a series of points down. So in this question, they actually don't give you any specific points. So what you can do is you can just take a series of lines down yourself. So for example, I could take this line here, this line, and maybe one or two more then, just to close out the curve. So I might just leave it at that now and just see if that helps. If I need to put one more in here, I can. So the idea is the exact same thing again. We're translating the parabola along the surface. So what we're doing is we're taking our height here, we're plotting it to give us that height there. Take that width, and we apply it on this side and this side, because remember the parabola is also going smaller this way as well, but now you can see that this cut surface is reducing the height of the parabola even more, and we have 2 points there as a result. We go to the next one. We repeat the process again. Take our height there, mark it down from the top, and we're going to get another width. And now we take that width and mark it there and there. For the next one, I'm just going to use another colour again, just to show the process being repeated. So we'll just use yellow for example. And we'll take this height here, take this height on my compass, mark it from the top again, showing just to the left, I'm using that yellow height there, and then take this width there, mark it down there, there, and there is a bit of a gap in between the two in terms of drawing the curve, so I'm just going to put in one more then, just to get my curve as accurate as possible. Just take a point about here. So same idea again, take that height, step it down, So remember, stepping everything down from the top of the parabola. Never step it up, always step it down from the top, because the vertex is getting smaller and so it's going down that shape. So we always take everything from our top height B there. And then we take this width here, and that'll give us 2 more points on our parabola that appears in plan. So you can see there, our plan is now produced as a result. We'll just go over it in heavy. And that completes part C of the question there. And all that's left to do is part D, determine the true shape of the surface. True shape of surface AEC. So for this part of the question, I'm going to use rebatment to actually draw the true shape instead of drawing an auxiliary view. So an auxiliary view, if anybody wants to do, just take their view in looking this way, where they have their true length here, or looking in this way. So I have not much room in my sheet to actually do an auxiliary view going either way. So what I'm going to do is use rebatment, where I actually flatten the surface down on the ground to see it as a true shape and plan. So for example, that's a true length there. I'm going to rotate it around onto the ground and then use my widths, which always stay the same in the plan. Our widths never change, and step them out to actually give us our points on the curve. So for example, if I stretch out my compass to point E, I rotate it around so it's level on the ground. So I've rotated that around there. I take it down, and E extends out to here. That length there, the same as that, which automatically in the plan is going to be the same length there, and just extend my point out. So E is actually now out there for my true shape. After that then, I can just extend my other points. So for example, that point there, rotate it around to the ground. Always swinging your compass from here, there's the pivot point you're going to be using. I take these two down. If I follow it around, there's that point there. Extend it out, gives me a new point here, and gives me a new point here. I just carry out the same process over and over again for each of my points. So I extend out to there, rotate it around to the ground, take my points across, make sure to follow this line, and there's my point there, extends out to here, there's my point there, there's my line, extends out to there. I just repeat the process for the last two then as a result. So rotate that yellow one around, take it down, and where that line is there, across to there, extend it out, take it down to there, extend it out, and then finally my last point, rotate that around there, take it across there, and then find where it hits my curve here and there. And this now gives me the true shape of the surface AEC. that's my true shape there as a result. So that surface there is now my true shape. And just to show it in colour for anybody who wants to see, just use green for an example for one. At this length here, between there and there, is the exact same as this length here. So I'm just basically rotating that point down, doing it straight down, and following the corresponding point there and taking that out each side to give me my points. I hope that video helps anybody who's stuck on that question.